Okay guys, welcome back. Good morning or good afternoon, depending on when you're watching this. We are gonna go back to our proofs. We started these before spring break, but we're gonna revisit them now. And then we'll be doing these for another week or two as well. So let's remind ourselves, a proof is just it's an argument written in a logical fashion or manner. Okay. So we're gonna write it in a logical manner. We usually use that with two-column proofs, okay? So the two-column proof, we're gonna have our statements column and our reasons column. Our statements are gonna be things that we can say are true, okay? So things that are true. And then our reasons are why or how we know they're true. Okay, so when we complete proofs, we must use logic. Okay, and this logic comes from our reasons, so theorems, definitions, etc. Okay, to show what we know to be true, to make an argument. Make an argument or statement be proven. Okay, so we've already talked through congruent triangles, so that's what we're gonna go to, and we're gonna work on congruent triangle proofs. Okay, so to prove triangles are congruent, we must use our knowledge to find matching angles and sides. Okay, in these proofs, often the given statements give us clues as to how to solve our problem. Anytime you're given is a sentence, it's a hint towards at least one more statement you can write down after using the knowledge you're given. Okay, so the given statements, okay, you're always going to be given and then you're going to ask to prove something. So these givens are always going to help you get to that proof. These are hinting at what we need to do. Okay, so our theorems, okay, we talked about these last a few weeks ago, I guess now, but we can use side congruence. So that's saying two triangles have three corresponding sets of congruent sides. Okay, so sides congruent to side, side congruent to side, side congruent to side. So we can say side, side, side. Side, angle, side. Okay, so that means we have a side congruent, another side congruent, and then the angle between them. So it's written as side, angle between them, and then side. Angle, side, angle is very similar, that the angle, two angles are congruent, and then the side between them is also congruent. Angle, angle, side is saying we have an angle, and then the side directly after it. So angle, angle, side, angle, angle, side. And then hypotenuse, leg, when two right triangles, okay, that should be the number. When two right triangles, so this only works for right triangles, we have our hypotenuse is congruent to the hypotenuse of the other right triangle, and then at least one of the legs is congruent, okay? Remember, with Pythagorean theorem, we can also then prove that the third leg is congruent, or we can use CP/CTC, which we'll talk about later, okay? But so all of these are going to be your last reason in congruent triangle proofs. Okay, so because this says to prove the two triangles are congruent, one of these statements will have to be our reason. Okay, so some tips. Draw on your diagram, and I'm going to show you how to do that. Okay, so draw and make those marks on the diagram, and then always start with your givens. Okay, and then something that's always going to be true, your last statement will be your prove, will be what it says to prove. Okay, so let's look at this example. They did not start with their givens altogether, but they do use both of them. Okay, so we're given that AD is perpendicular. Remember, this means perpendicular. So AD is perpendicular to BC, and BA is equal to AC. So they started by saying that the AD and BD were perpendicular, okay? So that means we're gonna have a 90-degree angle. The reason for that is given. ADB and ADC equal 90 degrees because that's the definition of perpendicular, okay? All of us know that that's this thing, but we have to make this very clear and laid out, okay? Think about it as if we're writing a recipe, okay? So let's add that. Think of proofs as a recipe. Recipe for someone to follow. Okay, so think of it as a recipe that someone has to follow in order to know how to make something. So you have to be very clear on the steps. Okay, so they said it's perpendicular because it's given. They said that those angles equal 90 degrees because that's the definition of perpendicular. And then we know that ADB is equal to ADC. So ABD and ADC are congruent because that's the right angles congruence, okay? All right angles are congruent, okay? Then we know BA is congruent to AC, okay? So I'm gonna go ahead and mark those with the line to say they're congruent on the picture, okay? And the reason is because that's given. And then we know AD is congruent to itself, AD, by the reflexive property. So again, we're gonna mark that in our picture. And then we have a side, and an angle, but we can't use that theorem. We know these are right triangles because it makes a right angle, and the hypotenuse is congruent, and then one leg is congruent. So we can use our proof statement, ABD is congruent to ACD by hypotenuse leg. Okay, let's try the next one. Okay, so we're given this diagram and we're given AC is congruent to CE, okay? So we know those are congruent, and DC is congruent to BC. Okay, so my first two statements, I'm gonna say AC is congruent to CE, and the reason is because it's given. Okay, we were given that information, so we know it's true. And number two, DC is congruent to BC, again, because it's given. Okay, we are trying to prove that triangle ABC, sorry, this should be ABC is congruent, because those aren't lines there, so we have to do then ECD. Okay, so that should say triangle AB is congruent to triangle ECD. I'm sorry about that, guys. So that's what we're trying to prove in this one. So we're given these two pieces of information. So those are going to be our givens. Okay. I also know that angle ACB and angle DCE are congruent because they're vertical angles. So my statement is going to be angle ACB is congruent to angle DCE, and the reason is because of vertical angles. So now I have a side, an angle, and a side, an angle, and a side. So I can say triangle ABC is congruent to triangle ECD by side angle side congruence theorem. Okay, so a lot of times before you guys were just looking at the picture, now you're just writing the steps for the picture. Okay, so you're helping someone that they can then look and be like, oh, that's why we say they're congruent. Okay, let's look at example 2. Okay, so we ended up skipping number 2. That one just had a lot of typos, so we're gonna go to number 3 and 4, and then we're gonna add a second part to these triangle proofs. In number 3, we have these two triangles. We are given that angle E is congruent to angle F, and EF is congruent to RQ. Okay, we are also given that EG is congruent to PR. Okay, so angle E is congruent to angle R. That's a typo. It's marked here correctly. I'm sorry, guys. EF is congruent to RQ, and EG is congruent to PR. Okay, so we're gonna write our givens. So angle E is congruent to angle R, and that is because it is given. EF is congruent to RQ, also given. And then EG is congruent to PR, also given. Okay, so we're given a side, an angle, and a side, an angle, and a side. So our proving that triangle EFG is congruent to triangle RQP, that is by side, angle, side congruence theorem. Okay, so that one was a little bit more straightforward. Everything we needed to prove was given. We just then had to write it out to be like, okay, this is all given, therefore we can say it's congruent by side, angle, side. Okay, in example 4, we're given angle B and angle G are congruent. And then we're also told that CB, this means parallel. So CB is parallel to GA, okay? And a lot of times to notate something's parallel, we use these little arrows to say those two lines are parallel for us, okay? So we're given two angles that are congruent, sides are parallel, and we're trying to prove the triangle BCA is congruent to GAC. Okay, so our first statement is going to be that angle B is congruent to angle G. Our reason is because it's given. Our second one is going to be that CB is parallel to GA, also given. Okay, now we're given that they're parallel. When you see that two lines are parallel, you need to think about transversals. Okay, that's going to be super helpful for these because we have our parallel line, and then CA is acting as our transversal. So with that, we can then say that angle GAC and angle BCA are congruent because they're alternate interior angles. So angle, make sure you give all three letters for this. GAC is congruent to angle BCA. I need to give two on there, I'm sorry. So because angle B and G have the one arc, we need to do two arcs here, okay? To show that they're not congruent to each other, but which ones they're congruent to, okay? So we can say these two angles are congruent because they're alternate interior angles. So now we have a side, or we have an angle, we have an angle, we have an angle and angle, okay? We can also use that CA is congruent to itself CA by the reflexive property. Okay, and then now that we have an angle aside, an angle and aside, we can say triangle BCA is congruent to triangle GAC by angle side congruence theorem. Okay? So, we can prove triangles are congruent. We can also then prove that parts are congruent within the triangle. This is just adding that extra step that once we prove the triangles are congruent, we can use CP-CTC. Okay? Remember, CP-CTC is corresponding parts of congruent triangles are congruent. So it's saying if we know two triangles are congruent, then their corresponding angles are congruent, their corresponding sides are congruent. Everything's congruent in both of them. They're the exact same. Okay, so to prove parts of triangles are congruent, we must first prove, super important, that the triangles themselves are congruent. And these proofs spin the first several steps, just as you did in the previous example to prove triangles are congruent. Only after you have proved the triangles are congruent, you use CP-CTC, okay? That's super important. CP-CTC can only come after the reason of a triangle is congruent or congruent statement, okay? So, this example right here, we're given AB is congruent to CB. Again, I'm gonna mark them because that helps me a lot. BDA and BDC are right angles, and then so triangle ABD and triangle CBD are right triangles. We're trying to prove that angle A and angle C are congruent. Okay, so we are given AB is congruent to BC. That's given. We can then say that angle BDA and BDC are right angles because, well, actually, we're going to say right triangles. That's going to help us save a step. They're right triangles. Okay. We need BD. I am so sorry for all the typos. BD is congruent to itself by the reflexive property. Okay. So then we can say triangle ABD and triangle CBD are congruent by hypotenuse leg. Okay, so we have now said that they're congruent. We can then use CP-CTC. So we know the triangles are congruent now because their hypotenuse leg is the reasoning for that. So now that we know that this triangle is congruent to this triangle, we can now say that we know angle A and angle C are congruent because corresponding parts of congruent triangles are congruent. Okay, so now that we know that these two triangles are congruent and equal, we can say any part. Okay, we could say AD and DC are congruent because corresponding parts of congruent triangles are congruent. We could say angle ABD and CBD are congruent because corresponding parts. But it wants us to prove this, so we prove that by CP-CTC. Okay. In our next example, we're given that line XY is congruent to line ZV. Okay, so we have that marked. We are also told that XY is parallel to ZV. Okay, and we're trying to prove that XW and VW or WV, WV are congruent. So we're gonna start with our givens. So XY is congruent to ZV, and XY is parallel to ZV. So those are given. Again, guys, we are wanting to, since this is parallel, let's look. We have parallel lines and then our transversal. Okay, so we could say the angles are congruent. Okay, so we can say angle WXY is congruent to angle WVZ. Okay, and the reason that is true is because they're alternate interior angles. Okay, so we know that this is congruent. We have this angle. We can then add that these angles are congruent. So angle XWY is congruent to angle ZWV. And the reason is because they're vertical angles. Okay, so now we know we have a side, an angle, a side, angle, angle. So we can say that triangle ZVW is congruent to triangle YXW. And the reason for that is because we have side, angle, angle, or angle, angle, side, congruence theorem. Okay. So we've proven the triangle is congruent, so we know that this triangle is congruent to this triangle. Because they're congruent, we now know that XY, or XW, I'm sorry, and WV have to be congruent because corresponding parts of congruent triangles are congruent. Okay? And number 2, we're given angle RSP and angle QSP are right angles, and QP and RP are congruent. Okay, and we want to show that SR and QS are congruent. So we're going to start with our givens. And then we know QP is congruent to RP. Okay, so because we know they're right angles, in our head we know that means they're equal, but we have to write it. So angle RSP is congruent to angle QSP by right angles, congruence theorem. Okay, and then we know SP is congruent to itself SP by the reflexive property. So we know that triangle RSP is congruent to triangle QSP by hypotenuse leg. Because they're right triangles, we have our hypotenuses are congruent, and then one leg is congruent. Because we know the two triangles are congruent, we can say SR is congruent to QS by corresponding parts of congruent triangles are congruent. Okay guys, so let's go ahead and summarize with triangle proofs. You always start with your given. Okay, you're always going to start with those given statements, and your reason is givens. Make sure you are marking and drawing on your picture. If your proof statement is a triangle is congruent to a triangle, your reason at the end is going to be one of these: side, 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 angle, side, angle, side, angle, 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 side, HL, okay? Any of those. And then if your proof statement is saying parts are congruent, so like some angle is congruent to an angle, or a segment is congruent to a segment, you must first prove the triangles are congruent. So you'll have one of these in your reasoning proof, and then you can use the corresponding parts of congruent triangles after that, okay? So your corresponding parts of congruent triangle reason is always after this in your proof, okay? It's never going to be before one of these, it's always after.